Hey guys, and welcome back. So by now you should already know how to create good test cases and write up good defects, even if you have a piece of pen and a paper. And I promised during my last video that today we're going to be covering a defects lifecycle and also going through a defect management tool, in this case Jira. But I decided to split the videos in two and split the topics in two to firstly cover a defects lifecycle and then move into the whole different aspects of Jira and any other tools as well, just so that it's not too confusing for you. So stay tuned and let's look into it. Alright, so what I have in here is basically a Google Images results page for different sorts of defect life cycles. It's basically as random as it can possibly get. It's just literally me searching for defect life cycle on Google. And the reason I did that is I want to show you how almost all of the defect life cycles are the same. They get different. They can have certain differences. They can get more complex than not in some cases, depending on what the project or the team needs. But they all follow the same logic. And let's go from something very simple to some more complex ones in here, just literally by looking at how many boxes there are in a picture, so that you follow. I would follow the same logic as you would to try to get from an easier one to a more complex one, and then together we will find out what actually the similarities of all of these are. Right. So when you raise a new defect, as we covered in the previous video, when you report a new defect, even if you would have it on a piece of paper, only having a pen in your hand, you would want to somehow track a status of the defect. We covered that last time. And let's say every time you want to report a new bug, at the top right corner of your paper, you would write status equals open or status equals new, doesn't matter. And then you would hand it over to a developer to fix that defect. What they would do once they fix it is they would want to somehow track that status again. They would say, okay, now I fixed this defect. So they would strike through your open status, and at the bottom they would write fixed. And they would return this defect to you, the same piece of paper. Then you would have a look at the new status saying it's fixed. And then you would go to your product, you would try to test it, retest it, to make sure that this defect is indeed fixed. It's not occurring anymore. You would test it out, follow the exact same steps, and if your expected result is now met, then you would say, okay, fine, this defect can now considered to be closed. And then you will close the defect, you will scratch over the fixed, you will write closed, and you will put it in some archive box somewhere. And if, for example, the defect doesn't pass your testing, or you retest it and the same observed result can still be seen and your expected result isn't met, in this case you would want to return the defect to the developer to say, hey, fix it again, you haven't fixed it well, it's still not working as it should be working. So you would scratch over again the fixed status, but in this case, instead of writing up a closed status there and putting it in an archive, you would have to come up with another status to call it, I don't know, something like failed retest or reopened or whatever else. So you would scratch over, write that, return to a developer. Then they would fix it again, scratch over that, write fixed, and return it to you. This is what would happen, and this is essentially what really is a defects lifecycle. This means that a defect goes into different phases while it's still there, while it's still relevant. And these phases will be tracked with statuses, and you will basically be tracking these statuses, and when you have 100 defects, it will be very easy for you or for the whole team to navigate into what is our general state of quality in terms of defects based on what statuses they are in or based on what phases in their life cycle there are. Hope this concept is clear, and now let's validate this on examples of these diagrams. So here, in this case, you have a new defect which you're just about to raise, and there are two options from there. Yeah. So when you raise a new defect, it can happen that it gets rejected. So I didn't cover this in the previous example that I was telling you, but it could be that you raise a new defect, you hand it over with this piece of paper, and the developer says, nah, I scratch over your new status and I say, this is not an issue. He writes not an issue or rejected non-issue or whatever else, and he returns it to you explaining that this is working as it's expecting to be working, and you just misinterpreting the situation as a defect. So this is one extra case in this situation. Yeah. So from new status, it could go to rejected status and goes to archive if you agree that indeed this is not a bug. Or it goes into an open status, which means like a new status. So if we consider this the starting status in this case, then maybe this rejected status should be, branching out from this open status. Maybe just a fault of the diagram, but still. So from here it goes into fixed status as we discussed, and then this means that developer has indeed fixed the issue, and then it comes to you in a retest status. Don't worry about the naming, it can be anything you want in here in terms of the names of these statuses. Then you either close it and it goes to archive, or you reopen it and then it goes into the same cycle of getting fixed, coming back to you to be retested. There's also another one in here called deferred. This would be a case where you as a team will decide that the defect is indeed a valid one, but you don't want to fix it during this iteration of the software or of the product that you're building, and then it would be deferred to a later version, to a later iteration. So it is a bug, and you will have a different stack of bugs. Let's say if you would have the same pieces of paper, you'd be like, okay, this box is for 1 year later from now, and you just put it there. Cool, so you see the pattern matches with what I described, and there's nothing in here you wouldn't be able to do again if you were only writing defects on a piece of paper. It just would get much more complex to scratch over them all of the so many times and returning them back and forth and so on and so forth. So cool. Now let's have a look into another one, a bit more complex, and try to explore it together. What is this one? Cool. I even have some notes next to them to explain. So again, you find a new bug, you raise it. Let's assume it starts with this new status, then it can move into an assigned status. Doesn't matter, right? So another status in between, the idea is still the same. This might mean that it is with the developer, most likely would mean that it is with a developer already, or could be that it's with a senior tester, like once you change an assignee of the defect, you say, okay, now I assign this defect to whoever, guy number 1, and then you also change the status to be assigned. From here it says this goes, and from assigned status, let's see what happens. Okay, nothing flowing out of assigned. So it moves to an open status, which means that, I guess in this case it would mean, yeah, that it is considered to be a defect worth considering from this point on. Again, this is it could be very specific. This might come from anywhere pretty much. It's very random, but moves to open. Again, same situation, and from here there is a bit more options again, and the previous diagram was a bit more simple. In this case they've decided to add some more, and let's explore them. So it says duplicate. What this would mean is there is already a bug like this existing in our big box of other bugs. So someone else reported this same bug, and now you're reporting this as a duplicate. In this case, this bug would get closed, as you can see, and would end up in your archive because it's not valid in a sense that it's already raised and we're tracking it elsewhere. Then it might get rejected, which we just discussed, meaning like this is not a bug, this is working as expected, and if you agree with that, it goes into a closed status again and goes into an archive. Then there's different statuses as well. This is very, very, very specific or very arbitrary. In different cases, you might not even need this data issue, or you might need this, you might need a bunch of this, or even more than this. Doesn't matter. What normally data issue would mean that this is not an issue with the code that has been written, the functionality, but it's basically bad data, bad test data created, which would normally not be occurring in real life production scenarios. And you might want to track defects with this status as well and close them with this status as well. And then it would again move to a closed status and then go into archive. Or deferred, which we already discussed as well, means like this is going to be fixed later and not right now. So it's going to end up in a separate box to say, okay, this is a bunch of bugs which we're going to deal with later. Alright, now or other than this status, it can get fixed and then retested again. We covered this one, ready for retest. Okay, from here they've added a new status to say, okay, this is fixed and ready for retest, which essentially would be the same thing, so seems a bit redundant to me. And then it would basically move into a retested status, as in it's been fixed in this case, and yes, a tester agrees that it's been fixed, and then it would go to closed and rest in the archive. And again, as in the previous example, you might want to reopen a bug from the stack of your archive in case it occurs again, like some regression happened on the platform or on the product, and one of the older bugs is now valid again, and you are taking it out of archive, scratching over the close status and saying, I'm reopening this because this is occurring again. And then it moves back to the same life cycle. Right, so if you have a look, if you literally Google yourself defect lifecycle and try to look at the images like this, you will get to see that almost all of them follow the same flow. In very rare circumstances, you might need a completely different flow, but in case of defects, all of them will have the same logic. Some of the things will be fixed, some of the statuses will always be the same. So you would always have a new or an open status, you would always have a fixed status, you would always have a closed status, and this is where the whole process then happens in between. Whatever you else in there, in between these statuses, doesn't really matter. You will always understand it for as long as you know that this is just a way to keep track of the bugs. And always remember that all of this can be done also on a piece of paper and a pen, but it would be very hard to do it, so we would need to be tracking and managing this in more complex tools, defect management tools, which we will discuss in our next video. So I hope this video was helpful for you guys, and in the next video we're going to look into Jira. We're going to be raising defects there using the knowledge that we have already gained from the previous videos. We're also going to look into defect lifecycle in there on an actual tool, and we're going to explore the tool a little bit better to give you a better understanding and a more real life situational kind of instruction on what you would have to be dealing once you get introduced to the tools in your new workplace in future. So thanks a lot, stay tuned, and I'll be seeing you next week.